Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Mastera. Today we're going to be talking about GitHub Actions and the GitHub API and how you can use that in apps. So today I wanted to look at GitHub, and I wanted to look at GitHub because of its relationship to Azure. Now, I've talked about GitHub in the past with GitHub Actions and the like, but this one I wanted to look at it through just the lens of using GitHub itself as something that you might want to incorporate into applications. Now, GitHub has a very rich API, and it also has the ability to automate things. So it makes it a good platform for doing all kinds of things that are automated or through DevOps. So what I did with GitHub Actions is I wrote this little app that basically manages a queue of tweets that get posted to Twitter. And so I use the API as the backend for the application, and then I use GitHub Actions to automate posting tweets to Twitter. And this is an iteration of something I've already done using similar things on GitHub Actions, but this one was specifically built using everything on GitHub. And there's really no Azure components to this other than maybe hosting the file, which can really be hosted anywhere. But I wanted to look at this application. It's just really just more of an exercise in just playing with the APIs and doing something with GitHub Actions than it is anything of practical value, but maybe it will be to you. So let's dive right in and look at this little application I wrote, and we'll look at it through the lens of GitHub Actions and the GitHub API. So I wanted to start off by demoing this application. It's pretty straightforward. I'm not very good at UI design, so you'll have to pardon my utter lack of elegance in my UI, but the application is pretty straightforward. It just basically shows my tweets, and I have about 150 tweets in my queue right now. And the application allows me to add, remove, change the order, different things like that. And basically what that allows me to do is put a tweet at the top of my queue, and then whenever the backend fires, it'll take the latest tweet at the top of the queue and then post it over to Twitter. Now, I have a couple of things that I've done to make this a nicety. I have some categories right here, so I can set up different posts at different schedules for different categories. So if I wanted to post tech twice a day, I can create something in the backend that will post the tech tweets twice a day. And if I wanted to post something about writing, which I do a fair amount of, I can post about that as well. So I could filter these based on writing. So I could post one of these a day. Maybe I could post 2 tech tweets a day or something like that if I wanted to. But I filter them using this menu right here, and I could post 2 of these, 1 of those, or whatever it might be. And I mark it as evergreen to basically recycle the tweet. So evergreen content is basically content that doesn't get stale, or maybe it gets stale over a long period of time, but it just basically is useful. So I can keep a tweet in my queue. Basically, if it's evergreen, it'll post it, then add it to the bottom of the queue as well. And so this is a fairly straightforward application just for managing the tweets. The whole thing's about 400 lines of code. It's really nothing fancy. But if I wanted to create a new tweet, I just create a new one. This is my tweet. And if I show the filter for shared, it's the only one for that particular category in here right now. Now, if I publish changes, it's going to save all that data. And if I look at this from all, they're still all there. I just publish changes for all of the categories. And now I have a new tweet in my queue. So that's the application. Now let's go and look at the GitHub backend for this to show you what's going on there, so we can kind of look at the code repositories. Then we'll look at the APIs and the actions. So this is the code repository for this application. This is pretty straightforward. You see here that I have an index.html, and that's the code for the application we just ran. It doesn't really have anything to do with the actual repo itself. I'm just keeping the code here so that it's together with the backend stuff that I have as part of this application. So the backend data store for this is this JSON file right here. And there is that tweet I just added. It is in the category shared. It is evergreen as false. And there's the actual tweet, text, and then it gets a GUID assigned to it. And so you see here that I have a whole bunch of these in this JSON file. So whenever I run the application in the browser, it actually calls out to the GitHub repositories and grabs this file right here and pulls it back over to the browser and then uses the JSON data. And then it reverses that process when it posts that data back through the API. And we'll look at that in a little bit more detail in just a second. But I wanted to first kind of look at the GitHub Actions component of this, because the GitHub Actions component is what does a lot of the heavy lifting for posting it to Twitter, although it's actually very simple. Every GitHub repo has actions associated with it. Now, I could not do justice for actions because there's a lot of things that you can do with actions. Really, it's pretty crazy the kinds of things that you can do in this. It's basically infinite possibilities because of so many things that you can do with the kind of code that can be invoked or the actions that are invoked inside of actions. Now, mine are pretty straightforward, and these can get really complex depending on what your needs are, but mine are pretty straightforward, and I think they make great examples for demos like this. I have two actions that I have configured as part of this repository. I have lazy tweeter tech and lazy tweeter writing, and they're really the exact same thing, but they have some different invocations that will run them. Lazy tweeter tech, I can invoke one of two ways. I can do it using a manual invocation using run workflow, or it can run on a schedule. But if you look at this one ran about 3 hours ago on a schedule, and if you drill down to this, you can see that things were run, and the three that are defined in my particular workflow are check out the repository, post something on Twitter, and commit the changes to my repository. And these first ones, these last two, are the ones that are built into the actions themselves. And this one ran pretty fast. It took about 5 seconds to run. So I think that this particular one took 3 seconds, and the checkout took about 1 second. But the whole thing really does not take very long at all to run for my particular actions. Now, other actions can take a while, but mine are really quick. They're just, basically grab something out of the queue and post it to Twitter, which is an HTTP post, but nothing too fancy going on there. If you want to see the output from that, this is what it looks like. It's just the console output from the script as it ran. So nothing fancy there, but the invocation of this, again, can be done on a schedule or manually. And I ran it manually a few times yesterday to debug it, but now I have it running on a schedule. So the way that this knows what to run is defined is over inside the repository in this workflows folder. And the workflows folder are pretty straightforward. I have two of them. Like I said, I have writings.yaml and tech.yaml. Let's take a look at tech.yaml, and writing really is the exact same thing other than a few of the parameters are different. Now, the anatomy of this YAML file is pretty straightforward. You have a name, which basically tells the name that we saw over inside of the Actions tab. And then it has the invocations, what is going to trigger this. And on a couple of things right here, mine runs on a schedule or manually. And the schedule is basically a cron job, and it runs twice a day. So that's what this cron job represents at 11 in the morning and 2 in the afternoon GMT. So that's basically in the morning time where I'm at on the East Coast of the United States. Or I can run it manually with workflows. Now, you can run on pushes, pulls, whatever it might be. There's a lot of different things that you can put into this on right here to trigger this. So if I wanted to run this every time something got pushed into my particular repository, I could do that. And for some actions I have in other repositories, that's perfectly fine for my websites. So when something gets pushed into my repository, it publishes those changes over to my websites. So that's one way to use actions. But this particular job posts something to Twitter on a schedule, so it's very straightforward. So what this does is it checks out code right here. That's my first step. But to kind of give you an idea what this looks like, I have jobs. And if I have a GitHub action with multiple jobs, jobs will run in parallel unless I configure it to do otherwise. But every job has multiple steps that run in sequence. So jobs will get invoked in parallel, and they'll run in parallel, but the steps inside of each job are run in a sequence. So my steps are defined in order, so the job is going to execute those in order. I only have a single job on mine, so that's fine for what I'm doing, but if I wanted to have multiple jobs, I could definitely do that. So my steps are pretty straightforward. I have a step to check out my code. I have a step to invoke my script, and then I have a step to push my changes back into my repository. Now, My checkout repository is needed for this particular one because the script that I'm going to be using is in my repository. And once it checks out my repository, it's going to invoke the script right here using this run action. And this run action right here basically runs some commands on the console. It's running npm install, which installs some node dependencies. And then it runs the actual script right here, which is, again, 50 lines of code, 55 lines of code. I think it's really airy too. And this is what actually does the post into Twitter. So once that runs, the actual script right here will change the queue file in my repository. So if it is executing against the queue, it will either remove something from the queue or add it back to the bottom of the queue if it's evergreen content. And so this running right here modifies a file. So I need to put that file back into the repository. And that's what this last action does down here. It basically just does a git commit and a git push. And so this will put it back onto the repository as a change. And so this basically allows me to take something out of the JSON file, post it over to Twitter, update the file locally, and then commit that back to the repository. And so my queue stays up to date with each run of my action. So let's go look at the actual script that this runs. But this, again, is pretty straightforward. Before we do that, we can just look at the writing one. It's pretty much the exact same thing. The only difference is it's got a different cron on it, a different title, and a different category right here when I actually invoke the script. So it's running on a different schedule with a different category. That's the only difference between this and the other one. The actual script it runs is a part of my repository, so it pulls this repository down and it goes into this twitter.json file right here. And you can see that this is just using the Twitter package that comes from npm, and it's using the fs package. And this is where it configures the client with the data it got from the secrets for the repository. And this is where it reads the category from the environment variable, or rather the command line parameters that I passed in as part of this. This is stood up as environment variables from secrets, so that's why this is set up like this. This reads it from the parameters from the command line, so this is basically the category that I want to post into this. And this is where it reads the JSON file. It reads it back in as just JSON data, and then it converts it to all the objects using JSON parse right here. And then it basically makes sure that there's something there. And if there's no category set, it basically just grabs something off the queue and posts it to Twitter. If not, it looks for something in a category. Using this loop right here, it finds the first one in the category. And then if it did find something, if there was something on the queue, it basically adds it back to the queue right here, records.push, queue tweet, post it to Twitter using this API call right here. And then if it was successful, it logs what came back off of the request, and then it writes the tweets back to that JSON file, basically to create the file with the new order. And so that's where it's modifying the data in this. And then, of course, the get commit and the get push will then update the actual queue that is as a part of this particular repository right here. So this one has something right here, and if I ran one of those jobs manually, you would see that it has a new tweet. So let's go ahead and do that invocation manually, just so you can kind of see that happen. And so I'm going to run lazy tweet tech right here and run this one. So it's going to post something new to Twitter, and we can see that actual run as part of my action right here. And this will take a few seconds to run. We'll come back when that's finished. Okay, so that completed. And so if we go back over here and look at my my queue, I should be able to see something changed on my queue right here. So that updated 12 seconds ago. And if I look at this, we still have that shared one that's right there, but this one is no longer. This is the latest one. We should see the next one for the tech queue. If I come back down here at the bottom, we should see that one about star schemas. That one got added back to the bottom of the queue by my twitter.js file. So that's my queue right there, and it's just basically posting something to Twitter. Now, if I go over to Twitter right here, and I click on my profile, I should be able to see that tweet show up right there. That's the latest one right here. using that star schema one that it just posted 45 seconds ago. So again, it just posted it over to Twitter using that action. Now, again, that's going to run on a cron job, so I'll be able to see that run throughout the day. So it's going to run my writing one twice a day. It's going to run my tech one twice a day using actions. So now that we've talked about actions, I want to talk about the other side of automation on GitHub, and that is through the APIs. GitHub is a really powerful set of APIs that basically allow you to do anything that you can do in the portal using the API calls. Now, there is a ton of things you can do. I can only really address a few of these in my application because it's a pretty small subset of the entire suite of things. Now, you can definitely check out the documentation to see all the things that you can do, but a few of the things that are very useful for my application is get code from the repository and check code back into the repository. And so to do that, I'm just calling an endpoint that basically downloads a file or uploads a file, and it will basically do a commit if I do that. So if I pull it, it's just basically cloning it or just getting a copy of the file. If I upload the file, I'm doing a full commit to that file, and that's what we'll see in my example here. So this first example is where I'm actually getting the data from GitHub. I'm downloading the data from GitHub from that tweets.json file that we did look at. And so this API call is using an endpoint that I'm populating from a settings file or settings object rather that I have populated in the application. So this is basically going out to this settings username, getting the repository, and then there is the path to the particular file that I care about, which is tweets.json. And to access that, because mine's a private repository, I need to give it some authorization. I'm using an personal access token for this particular access right here, and it uses basic auth as part of that. So I'm using my username and my personal access token to authenticate against my private repository that I have this code in. I'll link this to a public repository that you can download and play with it, but this particular one right here is using a personal access token and my username to authenticate. Now, the personal access token is probably not the best way to do this. You could you might want to think about other authentication mechanisms. For my use case, it works fine because this allows me to do this in a browser. And what I'm posting really isn't that big a deal. It's just tweets. So if somebody was to get into this and do something, I probably would cry a little bit, but I'm not going to lose a lot of sleep because it's not giving away a lot of secret information that I really care about. But if you were kind of paranoid about this, maybe create a new GitHub user and create a repository solely for this purpose or something like that. I mean, there's a lot of ways you could approach that problem. But in any case, once you have the authentication set up, basically I'm just calling an endpoint, and that's easy to do. api.github.com, repos, here's my endpoint, go get me something. And it pulls back the file, and I parse the file right here because the content comes in as a JSON file. Then the actual JSON data in my file comes in as base64 data. So that's why I have this additional JSON parse right here. And then I basically do some stuff with it, and now I'm off to the races. So let's look at the other location where this is called. So let's find that in this file. And this is where it actually does the upload. So once I've edited all of my data and I'm done, I'm happy with the way things are in my queue, now I can post that back into GitHub. And that's what this one does. It does pretty much the same thing. It populates some header information, and then it calls a new endpoint. This one is basically the same endpoint, actually, with a different verb. So the method is put instead of get, and the headers are pretty much the same, but it creates a upload body right here where it basically needs to know what my commit message is, who's committing it. You know, that's my username and password. I need to pass in the hash for the previous version of this file to make sure that there's no collisions there. So when I downloaded it, I stored the hash for the previous version. And then, of course, the content I have to put into base64 encoded data. So I'm stringifying the JSON data and then doing a base64 right here and storing that content. Then right here, I'm storing that as the body on the actual post. And then that gets uploaded back into my GitHub repository using the API. And so again, the APIs are pretty straightforward. They're just REST APIs that you can use to download, upload data to this. You can create branches, you can merge branches, you can invoke actions, you can create new repositories, You can delete repositories. There's all kinds of things that you can do with the API. So the API combined with GitHub Actions creates a lot of possibilities just within the context of GitHub. Now, the GitHub terms of service don't allow you to write applications against GitHub. You couldn't use GitHub to host a serverless application. However, because I'm using my application to manage my GitHub repository, that is kind of within the scope of what this is doing. So this really isn't doing anything to burden GitHub or doing anything that's going to really abuse anything on GitHub. It's just basically doing a demo for GitHub Actions and GitHub APIs using this little app that I wrote to manage a queue for tweets. So if this is something that you're interested in, check out the link in the video description below for the code, and you could maybe manage your tweet profile with it. I was using some others that you can download and do an app with it. I wrote my own just simply because it's pretty easy to do using GitHub Actions and also using the GitHub APIs to manage that through a simple application.